Hello everyone, and welcome back to the channel. In the previous video, we discussed the important topics from econometrics that are commonly asked in data analytics and related interviews. In this video, we'll move on to statistics. Now, this is not meant to be an in-depth explanation of every concept. The goal of this video is simply to provide an overview of the important statistical topics that every aspiring data analyst should know. Later, we can dive deeper into each topic individually. So, let's get started. The first and probably one of the most important topics in statistics is probability. Probability helps us quantify uncertainty. In simple words, it tells us how likely an event is to happen. Many advanced concepts in analytics, machine learning, and data science are built on probability. Within probability, one important concept is conditional probability. Conditional probability simply means finding the probability of an event given that another event has already occurred. Another very important topic is Bayes' theorem. Bayes' theorem allows us to update our beliefs based on new information. It has applications in spam detection, fraud detection, medical diagnosis, recommendation systems, and many other fields. For example, suppose a disease affects 1% of the population, and a test detects the disease with 95% accuracy. Using Bayes' theorem, we can estimate the actual probability that a person has the disease if the test result comes out positive. The main idea behind Bayes' theorem is that probabilities can be revised whenever new evidence becomes available. Moving ahead, another important topic is correlation and covariance. Both of these concepts help us understand relationships between variables. Covariance tells us whether two variables move together in the same direction or opposite directions. However, its magnitude is difficult to interpret. Correlation, on the other hand, standardizes this relationship and always lies between -1 and +1. A correlation close to +1 indicates a strong positive relationship, whereas a correlation close to -1 indicates a strong negative relationship. If the correlation is close to 0, it means there is little or no linear relationship between the variables. One thing to remember is that correlation does not imply causation. Just because two variables are related does not mean that one variable is causing the other. The next important topic is hypothesis testing. Hypothesis testing is used to make decisions based on data. In simple terms, we start with a null hypothesis, which represents the status quo or no effect, and an alternative hypothesis, which represents the claim we want to test. For example, suppose a company launches a new marketing campaign and wants to determine whether sales have increased significantly. Hypothesis testing helps us decide whether the observed increase is statistically significant or simply due to random variation. While studying this topic, concepts such as p-values, significance levels, type 1 errors, and type 2 errors become extremely important. Next comes sampling. In real-world scenarios, collecting information about an entire population is often expensive and time-consuming. Therefore, we select a smaller subset called a sample and use it to draw conclusions about the population. Common sampling techniques include simple random sampling, stratified sampling, systematic sampling, and cluster sampling. Understanding sampling is important because the quality of your sample directly affects the quality of your conclusions. Finally, we come to distributions. Distributions help us understand how data is spread. Some commonly used distributions include the normal distribution, binomial distribution, Poisson distribution, and uniform distribution. Among these, the normal distribution is particularly important because many statistical methods and machine learning algorithms assume that data follows a normal distribution. Understanding distributions helps us perform hypothesis testing, confidence interval estimation, and many other statistical analyses. So, these were some of the most important statistical topics that are frequently asked in data analytics, business analytics, risk analytics, and data science interviews. In the upcoming videos, we will explore each of these topics in much greater detail, solve examples, and understand their practical applications. If you found this video useful, make sure to like the video, subscribe to the channel, and share it with others who are preparing for analytics interviews. Thank you for watching, and I'll see you in the next video.